Hello, I'm Sagnik Mitra, and this is my approach and prototype for the vehicle routine problem. And this approach was inspired by the author Dewey. So this is basically a demo simulation for testing purpose, consisting of a database having 536 rows, among which the first row is basically considered as the warehouse, and also like where the is customer function returns 0. And also I have a 5000 rows generated CSV dataset that I'll be using for the main program. So as like it is hosted on Streamlit, so the Streamlit platform crashes if I use a big dataset. So there are thousands of graphs generated. So I use this for testing purpose. So now first of all there is a slider. So the slider has a default value of 10 and it has a max value as the length of the location.csv mentioned in the above CSV, and also the main value is 1. So first of all, we get the latitude of warehouse and the longitude of warehouse, and next the number of customers. And here we can see the view the customer and warehouse input plot. So this is basically the customer and warehouse plot. And after that we have the global one centroid. So basically how the global one centroid is a cluster at 0. And also like we have the codes mentioned here, what codes we followed through. And also this is the centroid location. This is basically the warehouse centroid location, and average distance from centroid is basically calculated to the np.mean function, and threshold distance from centroid is basically calculated from np.percentile function, where the parameters are distance and percentile. Next we have all the centroid. Basically we took default 10 vehicles, and also I want to show something that we can generate this for real time. So let's say I want to do this 45. So if I wait for 10 to 15 seconds, it will automatically generate the clusters. So I have done 45, it is loading. So now we can see that it is loading, and so we can see the 0 to 44. So 45 clusters are there. So now we have the updated centroid locations, and the file is still running. So this is the updated graph basically. So this is basically the updated graph for the warehouse and clusters. And so here I use the double divide operator while calculating the max capacity. That is basically the length of the customers divided by number of vehicles, and the resulted the max capacity to be 11 in this case. And if I use the math.floor function, it would be 11, and if I use the max capacity, basically the math.ceiling function, it would be 12. So in our case, as we have seen from the above text, so the max capacity is 11. Now the shortage capacity is 41, and the additional capacity per vehicle is 2. So this is calculated through the down code below. So the initial assignment of customers to vehicles is basically all the vehicles are first of all distributed 11 customers, and we can see the number of unassigned customers are 41. So what we did was, so we assigned this unassigned customer to the nearby vehicles. Okay, so the nearby vehicles are also, it is mentioned that which vehicle and which customer is assigned which vehicle. So after that we have the number of remaining customers, which is basically 0, and if it is not 0, it will run again and iterate over until and unless the remaining customers will be 0. All the codes are mentioned here in the important line of code. And so now we have the main part. So vehicle 1 is assigned 11 customers. So these are the points of customers assignment. So vehicle 2 is assigned also 11 customers. So so on and so forth. So I'm skipping this part. So all the basically these are the assigned customer map of all the vehicles. So we have the legends like vehicles and warehouse, and also the mark is here. Okay, so after this so we have, so after all the assigned customer maps of all the vehicles, so let's say we have 45 vehicles. So after that we have the two details. So two details, we have the best distance for vehicles, best tour, and also we have the total cost. So in tour of vehicle 1 we can see that the customers and the warehouse and the tour it will be going through, and also vehicle two details. So all the two details are here. So after all of this, so after all the vehicles and all of the two details and customer details, so finally, so as it is like happening real time, so it take some times to generate the data basically. And after all this, what it does is basically it generates all the total data and gathers all the data in one. So this is basically my prototype, and this is my code. So the code, so I basically visualized this with Streamlit and use libraries like math iter tools for iterations, and collection named tuple for collections, and pyplot and sklearn.cluster, and linear algebra library. And this is basically the code is also uploaded in GitHub and also mentioned in my proposal for Loginext. Thank you.